All right, so looking at some examples on the geometry ones. So we are starting on at the bottom of page 4. So we're looking for area and perimeter or circumference, depending on the figure, and use 3.14 for pi. So remember, circumference is just the fancy circle word for perimeter. So just use that formula, and don't forget the Math 40 formula sheet. If you have not gotten a copy of that done yet, I would recommend it. All right, so for the rectangle, all right, our perimeter is going to be, 2 lengths plus 2 widths. So 2 times 25 plus 2 times 15, which is going to be 50 plus 30, or a perimeter of 80 centimeters. And then area is length times width. So those two values, now we just multiply them. And that's going to be what? Should be 375. And then centimeters squared, because area, we're covering things with squares. Essentially what we're trying to figure out is, okay, how many squares would I need if I put a grid over this to cover it all? That is what we're looking for. So square units for area to cover that up. I'm going to skip over the square because it's essentially the same as the rectangle. You just have to remember that this side would also be 32 inches and everything else will be the same. And then with the circle here. So we have, in this case, a diameter because it goes all the way across. So our diameter is 12 yards, and you should immediately decide that the radius is 6 yards, because remember the radius is halfway across. You can use either one for the circumference. There's 2 circumference formulas that you can use, but you can only use radius in the area formula, so make sure you have that. All right, so circumference, we can do pi times d. So using pi as 3.14 and d is 12. And let me get my calculator. Is 37.68 and 37.68, and that is yards because it's just the distance around, how far around is the circle. And then the area, we're going to use that pi r squared formula. So 3.14 multiplied by our radius this time. So we're going to grab the 6 squared. So 3.14 times 36, which is approximately 113.04, and then don't forget that these are yards squared. So remember, area is like buying carpeting or painting walls. It's good, you buy it in square units. So typically square yards or square feet is what we talk about when we talk about those. All right, so we will flip to the next page here and do a couple of the so area of a shaded region one. So with these, I do recommend coming up with a basic plan, kind of, like your outline of a paper. For this one, I only want the shaded part. So the ones that I'm going to have that are these combination ones like this are going to be to either add shapes that I know how to find the area of together, or I'm going to subtract areas of shapes that I know how to find. So for this one, if I do the area of the big rectangle and I minus the area of the little rectangle, that's going to give me that frame in between. And then knowing that those are both rectangles, so I'm going to have a length times a width minus a length times a width, and then just making sure you're using the correct ones in the right place. So the big rectangle is 7 by 8, so 7 times 8, and then the little rectangle is 6 by 5.5. And so that'll be 56 minus, and then 6 times 5.5 is 33. So 23. And that is going to be inches squared. So all of the shapes with like this kind, you're going to be able to have enough information to figure out how to set that up. Like the next one, that one we want the difference between, we've got a circle on the outside, but we're punching a square, or sorry, square hole out of it. So I'm going to do the area of the circle minus the area of the square. Area of the circle, remember we're going to use pi r squared. And then the area of the square, you can, do length times width, or you can do sides squared. So I do have a radius here. It is right there, and that is the 5 centimeters. Sorry, it's not exactly with it there. So that is a radius is 5. And then the side length for my squares, so the length and the width are both 8 centimeters. And make sure that you're using 3.14 for pi. That is what Alex is typically going to do, so that make sure you're being consistent with that. And then subtract your area of the square, so 8 times 8 for the length and the width. So we get 78.5 for the area of the circle, and then 8 times 8 is 64, so we'll subtract that and get 14.5, and this is all centimeters, so centimeters squared for that shaded portion that is the circle minus the square. The next one, I was trying hard to get this to be a dotted line, but I just could not get it to do it. So I'm going to make that a little bit dotted there so you can see that it is in a whole room with like a little alcove area. So if I was thinking about doing this one, this would be a situation where I could add 2 shapes that I know how to find the areas of together. So I could add the area of the big rectangle plus the area of the little rectangle. Since I have this big rectangle and the little rectangle. And everything's all in yards, so I just need to pick out the right lengths and widths for each of those. So the big rectangle has sides of 18.2 and 7.5. And the little rectangle has sides of 4 and 3. Of course, that will be 12. And then let's go for the calculator on the other part there. So this is going to be 136.5, and then add that little alcove extra part to it. So 148.5, and that is yards squared. So this is similar to things that we looked at in Math 36 and Math 38, which is why I keep kind of referring to it as a room, because we had a similar room problem there. It doesn't say that it's a room, so don't feel like you had to know that. Okay, now flip to the next page and we'll look at some volume problems. And actually surface area first, pardon me. All right, so we've got our rectangular prism here. So surface area of the rectangular prism. So remember we've got 3 faces, and then we have matching pairs of those on top, bottom, left, right, front, back. So I will have 2 that are length times width, 2 that are length times height, and 2 that are width times height. And this would be given to you if we have any, but we're not going to have any of these on the test. There's no surface area ones on the test. And then I've got my length, width, and height. So it's just a matter of plugging those values in and using the calculator. So I'm deciding that one's the length, that one's the width, and that one's the height. let's see here, 1.5 times 7 plus 1.75 times 7, and a 2 in there as well. Sorry, missed the 2 there. Okay. And it's a good idea to write these things out because, you know, if you have it written out, then you can go to your calculator and be pretty sure that you aren't making mistakes by going back and forth to the calculator and to the paper. All right, so those add up to that. So all together, I have 103.25, and that is inches squared. Because remember, we weren't figuring out how much this figure could hold. We were figuring out how much paint would I need or how much wrapping paper would I need to cover this. So covering, we're looking at squared units. All right. Here, it would save you some time to use the square formula rather than the rectangular prism formula. To use, I'm sorry, not the square, the cube, because it's a three-dimensional figure. So the surface area of a cube, remember there's 6 sides that are each s times s. So this would save you a little bit. It's a little, not as long as having to do this one. So 6, and then this is 1.5 quantity squared. So 6 times 2.25, which is 13.5, and centimeters squared. Remember, it is an area measurement. Even though it's the outside area of a three-dimensional figure, it's still an area measurement. And the cylinder, so surface area there, we're going to have 2 bases, so 2 times pi r squared takes care of the 2 circle bases. And then the circumference of the base, so 2 pi r times the height, takes care of the rectangular outside that is not one of the bases. So radius is 1.2 inches and height 3.2 inches. And using 3.14 for pi. And making sure I'm plugging all of those things in correctly. And then going and doing a careful job typing this all in at my calculator. All right, so all together, once I've done my calculating there, I have this, and usually they're going to have you round it to either the tenths or the hundredths place. So I would do 33.2 approximately and inches squared for that surface area. All right, last one here, we have our sphere, and it has a diameter of 4.2, so I am automatically going to think to myself, all right, my radius is 2.1 centimeters, because that's really the only piece of information I need to do all of my stuff with a sphere. So I'm gonna pause here, and I will do the rest of this on the next video.